Now we are going to discuss about superposition principle. In last video we discussed force between 2 point charges. So we derived one relation, we derived force formula. So we told that Coulomb's force formula. Is it okay or not? So now today we are going to discuss what we are going to discuss: superposition principle. Superposition principle. Superposition principle. Why we needed this superposition principle? If we have 2 point charges, so we know very well how we can derive that force formula, either how we can find the resultant force. Is it okay or not? But if suppose that we have numbers of point charges, for example like this, okay, so if suppose that we are going to draw here, let us see, this one is a q1 point charge, and at certain distance here, okay, we are going to write here q2 point charge. Distance if we want to write, so we can write here r12, it means position vector. Is it okay or not? Okay, similarly if suppose that we have here also, this is q3 point charge, and here we can write position vector r13. Is it okay? Similarly if we have like this, here q4, okay, charge, so here is a 1,4, this is a position vector, and here suppose that we have q5 point charge, and here position vector r15. Is it okay or not? And here we have that 1 point charge qn. Is it okay? It means we have numbers of point charges, so we need to find resultant force on q1 due to this point charge, 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 due to this point charge. So we need to find resultant force on this q1. So if we are going to find resultant force means, so that is known as superposition principle. So that things we are going to do. So it means if suppose that we are going to find force on q1 due to this charge particle, so you know very well it will be this side f12, vector f12 we can write. Is it okay or not? Similarly we are going to write force on q1 due to this q3, so we know very well it will be like this f13 cap. Is it okay or not? Oh, f13, sorry, f13 vector. Okay, either we can say that vector f13. Is it okay or not? And similarly if suppose that we are going to write here force on q1 due to q4, so it will be this side vector f14. Is it okay? And similarly force on q1 due to q5, so we know very well it will be this side. Is it okay or not? So we can write here vector f15. Is it okay or not? So if we are going to write force on q1 due to this q1, so it will be like this. Okay, so like this, so f1 and we can write, and here we can write what we can write here, distance. Okay, so position vector r1 n, this is a position vector. Is it okay? You can mention, no problems. I mention only some position vector, rest of things, rest of you can do, no problem na? Very good. So now what we are going to do, we are going to find resultant force. So for the resultant force we need also unit vector. So unit vector for this one you want to write, so you can write r21 cap. Okay, and here for this one if you want to write here unit vector, so here you can write r31 cap. Okay, so here you can write here for this one, so r41 cap, here r51 cap, and here r, you can write what you can write here, n1 cap. Is it okay or not? First try to understand diagram. If you are able to understand diagram, definitely you will get right answer. So now what we are going to do, we are going to find resultant force. So resultant force f1 will be is equal to vector f1, sorry, here we can write here force on here na, so f vector f12 vector f13 plus vector f14 plus delta s plus vector f1n. It means what we are going to do, we are going to find resultant force on this point charge due to multiple point charges. Is it okay or not? Now you can write that formula. So you can write here f1, vector f1 is equal to, you can write 1 upon 4 pi epsilon naught into this one to this one. It means between these two charge particle. So we can write q1 q2 divided by r12 square r21 cap plus 1 upon 4 pi epsilon naught. Now between q3 and q1 you can write q1 q3 divided by r13 square R31 cap. Here is no space, so I am writing here plus. You can write here between this one and this one. Okay, so what you can write here, 1 upon 4 pi epsilon naught Q1 Q4 divided by R14 square R41 cap. Is it okay? So rest of you can write numbers of no problems. So plus dash 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 plus 4n. This one you can write 1 upon 4 pi epsilon naught Q1 divided by R1n square Rn1 cap. Is it okay? So you can leave here also, no problems. If suppose you do not want to write next, so you can leave here. This is also accepted, no problem. We got the resultant force formula. But if you want to make some arrangement, okay, if suppose you want to make some arrangement, so you can make like this arrangement. So you can write vector F1 is equal to, what is the common here? So Q1. So Q1 is everywhere, and 1 upon 4 pi epsilon is also everywhere. So we can write Q upon 4 pi epsilon naught. Is it okay or not? So now in bracket what Q1 you can write. Okay. So now you can write here Q2 over R12 square R21 cap plus, very good, Q3 upon R13 square R31 cap. Is it okay or not? And plus, okay, so here is no space, I am writing here Q4 divided by R14 square R41 cap plus dash 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 plus Q5 divided by R15 square R51 cap. Okay. Okay, so like this you can write or not? Very easy. Okay, what you did, you just took the common. What a common? Q1 is everywhere and 1 upon 4 pi epsilon naught is also everywhere. So you took common. So after this, what you are going to write? You are going to write final summation form. So you can also write F1, vector F1 is equal to Q1 divided by 4 pi epsilon naught summation over I is equal to 2 to I is equal to n. So you can write here Qi divided by R1I square R. Here the condition, na? So here what you can write here, I1 here cap. Is it okay or not? Like this. So this is required force formula. What force formula? Force on Q1 due to multiple point charges. So we got this final formula. You can leave here also. You can leave here also. This also true. Okay, no problem. You will get full marks. But please try to write completely. Okay, this is one important things I want to tell you. Okay, till here any doubt? So no problem. We will see you in the next video. And till here you please try to make note. If suppose that I didn't write here definition, so you please take the help of the book and try to write the definition. First you write the definition, after that you just start to derive this relation. Is it okay or not? No problems. Okay, so thank you so much.